Hello guys, Dr. Kate here. Today we're going to talk about the SN2 reaction, nucleophile, electrophile and living group. Let's move on to know about it. In any substitution reaction, one atom or group is being replaced with another atom or group. Here we have an example of hydroxide which is replacing to the boramine here in this structure. In any SN2 reaction, we should identify three main key players: nucleophile, electrophile, and living group. Nucleophile is something that has excess electron density. So this could be formally a negative charge atom or polyatomic ions, or could be something with lone pair, anything with excess electron density, like hydroxide here in this example. And I was always going to find the electrophile. This is the opposite side of the nucleophile with electron deficiency. Here, the carbon atom is electrophile because of the polarity of this bond. As you can see here, we know that boramine is more electronegative than carbon. So this is the covalent bond, meaning that this bond is partially positive charge on carbon and negative charge on boramine. So the negative charge of hydroxide attacks to the carbon in this structure. And also we should attention to the living group. Only carbon can get four atoms, so it should lose another atom when the hydroxide attack. Here we lose the bromine atom, and at the end we have methanol and bromine. Let's look at its mechanism. We should always care about the electron pushing error. These errors are depict the direction of electron flow, and they have to be drawn in a specific way. So we always going to go from electron rich to electron poor. This first error from oxygen atom here, uh, oxygen rich atom in electron, error starts from there and directly to carbon atom, because the electron deficiency on a carbon. These errors are going to be in the center of this bond between carbon and boramine. This covalent bond to leave by the boramine atom, and in leaving the boramine ion at the end. So watch this point in SN2 reactions, that the inversion happen when the hydroxyl attack from back lobe, and it invert to the structure of the S configuration from R to S or vice versa. In trip bonding SN2 reaction, there has to be a backside attack for the nucleophile always, and the highest occupied molecular orbital of what is doing attacking is going to dump electron into the lowest unoccupied molecular orbital of whatever is acting as electrophile. So here on this substrate, the lowest unoccupied molecular orbital is 100 degrees from the carbon boron bond. So here's the living group. That means that the nucleophile is going to have to attack precisely 180 degrees from there. So it's going to be on this way. And then for any other steps, we can always look at the transition state happen here. Basically, this is always happening in one step. SN2 reaction in one step, and two does not mean that it's in two steps. Um, so it's in one step. Two refers to the in fact that the biomolecular transition states, meaning that the substance is coordinated loosely, both the nucleophile and the living simultaneously in the transition state. Basically, we can see a partial covalent bond here beginning to form between oxygen and boramine. Thank you so much for joining me today. We have learned about nucleophile, electrophile, and living group in SN2 reaction. In next tutorial, we will study about how we can select the best ones. Join with me, subscribe to the channel. We will have a great journey.